All right, in 3.7, we're going to talk about how to experiment well. If treatments are given to groups that differ greatly when the experiment begins, confounding is likely. So you can have confounding in an experiment, so you have to be very careful. The solution to this problem is random assignment. In an experiment, random assignment means that the experimental units are assigned to treatments using a chance process. They don't get to choose, basically. They are randomly assigned. Okay? The random assignment should create groups that are roughly equivalent with respect to every variable that might affect the response. Random assignment works best when there are many subjects in the experiment. The idea that we should use enough subjects to create roughly equivalent groups is called replication. It's not good enough just to have two. You really need a lot more than that. Okay? So, although random assignment should create groups of experimental units that are roughly equivalent at the beginning of an experiment, there are other variables that might have an impact on the response variable. One reason to keep variables the same for each subject is to prevent confounding. So you might make a note of that. This is one reason to keep variables the same, is to prevent confounding. The second reason that we keep variables the same is to reduce variability. Okay? We've talked previously about the value of reducing variability in the response variable, making it easier to determine if one treatment is more effective than another. So you can see in this experiment, their variability is very small. All right? So this is probably a better run experiment here than this one. See how it's all spread out? The experimental groups probably were not randomly assigned on that. So let's keep going. Let's look at this. The cost of a meal might affect how customers evaluate and appreciate food. To investigate, researchers worked with an Italian all-you-can-eat buffet to perform an experiment. A total of 139 subjects were randomly assigned to pay either $4 or $8 for the buffet, and then asked to rate the quality of the pizza on a 9-point scale. Subjects who paid $8 rated the pizza 11% higher than those who only paid $4. Describe how the researchers could have randomly assigned the subjects to treatments using Part A, identical slips of paper. Okay, so we're just talking about how could the researchers have assigned them. All right, this is going to go back to when we did random sampling. It's going to feel very similar, but now we're talking in terms of an experiment. So there's 139 subjects, right? So we need to use 139 slips of paper. Now we have two groups, the $4 group and the $8 group, right? So let's write, we're going to write letter A on 70 of them and B on the remaining 69. Just kind of split it as evenly as we can. So we're going to write letter A, 70 slips. Okay? Then what we're going to do, we're going to hand out one slip to each volunteer. Okay? Customers who get an A slip pay $4 for the buffet. Customers who get a B slip pay $8 for it. All right? So that's all the question's asking me is how would I randomly assign the treatments to the people? It's just one way to do it. 139 slips of paper, you just randomly hand them out, A's and B's. Okay? Now, same thing, part B. This time it says describe how the researchers could have randomly assigned the subjects to treatments using a random number generator. Okay? So we're not using slips of paper this time. We're going to use that random number generator either in our calculator or some other way. So first thing we would do in this case is we would label the volunteers from 1 to 139. So label each volunteer a different integer 1 to 139. Okay? Then we would randomly generate 70 different integers from 1 to 139. Make sure you include the word different there because you don't want to have any repeats. Okay? different integers from 1 to 139. Okay, the customers that are selected, customers with the generated numbers, I should say, those first 70 will pay $4. The remaining 69 customers will pay $8. All right, so that's one way you could use a random number generator. Take the first 70, assign them to the $4 buffet, and the rest assign them to the $8. Could you have done it the other way? First group gets $8, the second group gets $4. Of course, it doesn't matter. You're just describing the method, okay? So let's move on. Example 2. Explain the purpose of random assignment in this experiment described in sample 1. Okay? The purpose of random assignment is to create roughly equivalent groups at the beginning of the experiment, taking out all, trying to eliminate confounding variables, making the groups as similar as possible. And that's true anytime you randomly assign. That's the purpose, okay? So I'd say the purpose, random assignment, is to create roughly equivalent groups at the beginning of the experiment. Okay? That is the purpose of random assignment. Always in first. All right, example 3. Are politicians more available to people who donate money to their campaigns? Researchers had members of a political organization attempt to schedule an appointment with members of Congress to discuss the banning of a particular chemical. Callers were identified as either a local campaign donor or a local constituent, with the identification determined at random for each member of Congress contacted. Otherwise, the protocol for the calls was identical, including the details of the meeting request, which were delivered by email. The results? The donors were more successful in obtaining meetings and were given better access to a higher level of staff, including the members of Congress. So part A says, identify one variable that researchers kept the same in this experiment. So it says that the protocol for the call was the same, meaning the conversation was the same. Okay, meeting request was the same. They were all delivered by emails. So probably the most important one is what they talked about in the phone call was the same. Okay, so I'm going to say that the details of the phone call to the members of. Okay, and explain how keeping this variable the same can help prevent confounding. Well, you can imagine if they talked about other things, they might chase rabbits and do other things. It could influence them getting an appointment. Okay, so it doesn't matter. They got to keep that conversation the same so that the only variable was were they a donor or not. Okay, so here's how to put it in words. If one of the treatment groups they were allowed to discuss different details during the phone call. We don't know if the details of the phone call or the caller's designation was the cause of the success rate. All right? So it's that whole keeping one thing, controlling your experiment of having only one variable going on. All right? So that's the value of that. So make sure you read carefully today and answer completely.